Welcome to Maths with EJD. In this video, I'll be talking about modularity and the Louvain algorithm, and that comes under the broad topic of community detection. So the next three videos will be on community detection, and so it's important to first of all understand what community detection is about in network theory. Community detection. Okay, community detection is a method in network analysis to identify clusters or groups of nodes that are more densely connected to each other than to nodes in other groups. Okay, so these next three videos are basically about techniques surrounding community detection, and in this particular video, our focus will be on modularity and Louvain algorithm. So let's go for that. Modularity, modularity, and the Louvain algorithm. Okay, so modularity measures the strength of division of a network into communities by comparing the density of edges inside communities to the expected density in a random network. Okay, a higher modularity, a higher modularity, a higher modularity score indicates higher modularity score indicates better community structure, better community structure. Okay, and this is talking about the part of modularity, modularity. So how about the Louvain algorithm? What does it look like? Louvain algorithm. So they are connected. That's how we take them together. The Louvain algorithm. Okay. The Louvain algorithm the Louvain algorithm optimizes modularity. It's actually, this algorithm optimizes modularity using a two-step iterative process. Okay. And the first step is this: assign each node to its community. Assign each node to its community, maximizing the modularity locally. Then the second step is to aggregate the nodes now. Aggregate nodes in the same community. Aggregate nodes in the same community. Mm. Aggregate nodes in the same community into super nodes. Into super nodes and repeat the process. Okay, so let's take an example of this and see how that works out. Okay, let's take an example. So consider a small social network with 6 users, because that's very small, but just for the sake of um this point we want to make, with 6 users and the following connections. So you have two groups. You have group one, that's A and B are connected in both directions. Then you have A to C connected in both directions and B to C connected in both directions in group one. Then also in group two, you have D to E connected in both directions. You have D to F connected in both directions. And you have E to F connected in both directions. So the first thing we want to do using this whole idea of modularity and Louvain algorithm is to first of all represent the graph in a matrix form. So we go for step one. So one, step one, we have the graph representation. Graph representation. If you remember, there are three ways to represent graphs, right? We have we have adjacency list, we have adjacency matrix, and then adjacency and incidence matrix also. So step one, the graph representation. So here we represent the network as an adjacency matrix. Okay, so that means that adjacency matrix A is the same thing as so you have imagine you have A B, C, D, E, F. These are the six notes. And then of course you have okay, let me bring it down a little bit. So you have A, B, C, D, E, F. And then this is A, B, C, D, E, F. Like that. So, of course, A to A will be 0. A to C, so you can see A to C are connected. A to C connected, A to B connected, B to C connected in both directions, by the way. So, A to B, B to A to C, C to A, B to C, C to B will all be 1, right? So we have 0. A to B is 1. A to C is 1. A to D, no. A to E, no. A to F, no. Then B to A is also, B to A would be 1. B to B is 0, B to C is 1, B to D, no, and then all this. Then C to A is 1 also, then C to B is 1, then C to C is 0, then every other one is also 0. Then D to A, no, D to B, no, D to C, no, D to D will be 0, D to E is 1, D to F is 1, because D, E, and F are in the same group. Then you have E to A 0, 0, 0. Then E to D is 1, E to E is 0, E to F is 1, like that. And lastly, you have F to A 0, 0, 0. Then this is 1, 1, 0. So that is the adjacency matrix for that situation that has been represented or that we have been given. So that's the first step. You represent what you have as a graph. You represent it as an adjacency matrix. So the next step would be to initialize. So we have step 2. Step 2 is initialization. Initialization. So here, what we do is we assign each node to its own community. Of course, we know ABC belong to community 1, that's group 1, and uh D to D ABC community 1, DEF community 2. So we have community 1, community 1. The collection of community 1 is A, comma B, comma C. And then we have community 2, that is D, comma E, comma F. So that's the second step. Then the next step is to optimize. So step 3, here we talk about optimization. Optimization. And here, what happens is we iteratively reassign, reassign nodes to maximize modularity. So for this particular graph we have now, for this graph, okay, we have nodes A, B, C, nodes A, B, and C form one community. Of course, just like what we have already. Maybe this whole thing will make way more sense if we have if we have a very large social media. So, I mean, what we are doing now may look a bit trivial because we have just few nodes. So, nodes D, E, and F form another community. And then after all this, we go to step 4. Step 4. So for step 4 now, we now do our modularity calculation. Modularity calculation. So for this now, using the using the modularity formula. We have a modularity formula. So using the modularity formula, which says Q is equal to 1 over 2m summation I comma j into aij minus kj over 2m, all of that multiplied by delta ci comma cj, like this. So this is the formula for modularity. Okay, so now where m is total edges, and that is 6 in this case. M is total edges. We have 6 here. Then we have ki. Ki is equal to the degree of node I. Degree of node I. Okay. So if you look at okay, maybe we can even okay, degree of node I, right? So imagine if you have node for node A, for instance, we have the degree will be 2. Node B degree is 2, node C degree is 2. I think for each one has a degree of 2 actually, because we have this back and forth connection like that. So that's what we have there. So degree of node I. So for either node A, B, C, D, E, or F, they all have 2 nodes. So if you say so, for instance, we'll be saying that KA, degree of A is 2, or degree KA, KB, KC, KD, KE, KF, all KF, all of that is equal to 2, basically. So that's KI. And then so if we say KI KJ, we are saying maybe if you're looking at maybe AB now, so you can have AAB minus KAKB over 2M or something like that. So that of course AIJ is actually the value of the adjacency matrix. So maybe I'm going to give an example of that. So AIJ actually are elements of the adjacency matrix. So e.g. KAB is equal to 1. Of course, because A and B have a connection. So KAB is 1, like that. And then KAD will be 0, to actually make that clear. So we have KAD, something like KAD would be 0 because A and D have no connection. Okay, so that's so we have the KIs, we have the AIJs, and then we have delta CI comma CJ will be equal to 1 if I comma J are in the same community, Okay. So but if they are in different communities, no. So at the end of the day, we can for the given network, for the given network, if you go, that's going to be a lot if you follow it through, like 1 over 2 times 6 summation. Then we now take all the elements. We have 36 elements in all. So I'll just go straight and drop the answer and move on. So for the given network, uh, we have it that Q is equal to 0.5. Okay, Q is 0.5, indicating a strong community structure. A strong community structure. Okay. So that's a very simple way of demonstrating the modularity and Louvain algorithm for community detection in network theory. Okay, so with this now, I believe okay, maybe I should just give this s small summary. I guess that should help a bit. So in summary, right, we can say that modularity, modularity and Louvain algorithm and the Louvain algorithm are effective. They are effective for optimizing optimizing community detection, community detection by maximizing modularity, by maximizing modularity, illustrated, illustrated in social networks, illustrated in social networks and collaboration networks. Hey, so with that, we come to the end of the end of modularity and the Louvain algorithm. Okay, so tune in, stay tuned for the next part of community detection, which will be talking about spectral clustering. So if you have not subscribed to this channel, go ahead and do that right now. Hit the notification bell also so you can always get alerted each time a new video is released. Comment, let me know if you want to teach a topic or solve a problem. And of course, like and share so that more people can have access to this great learning. Till I come your way again, keep networking, like I say. Bye.